Jai Hind to all. Myself Dr. Uma Sharma, Assistant Professor in EC Department at Akgec Engineering College, Ghaziabad. In the lecture series of VLSI Design, here we will discuss the CMOS inverter, its operation, and the very important concept of this CMOS logic design, which is known as the stick diagram. So, here in this lecture, we will see the concept how to implement the stick diagram. So, first let's see what is a CMOS inverter. So, CMOS inverter is nothing but a combination of NMOS and PMOS technology. Nowadays CMOS technology is very much popular in the field of VLSI design because of less power consumption. In case of CMOS technology, the static power dissipation is zero. Static power dissipation is zero because at a time only one transistor can on for any input, because in case of digital there are possibility of two inputs, whether input is 0 or 1. So, suppose input is 0, so in that case PMOS transistor is on and NMOS transistor is off, and when input is 1, PMOS transistor is off, NMOS transistor is on. So, you can see that at a time in CMOS inverter only one transistor can on. So, from that we can say there is no direct path exists between VDD and the ground. So, if there is no direct path between supply and ground, then it means static power dissipation is 0. So, in case of CMOS inverter, static power dissipation is 0. While switching, there is a dynamic power dissipation. So, overall the power dissipation is a combination of static plus dynamic. So, CMOS design consumes very less power, and that's why the CMOS logic design is very popular technology in the field of VLSI design. So, this is the basic concept of CMOS inverter. The operation is very simple. Inverter, why? Because if input is 1, then this transistor is on, and when NMOS is on, the output node is directly connected to ground, then output will become 0. So, when input is 1, output is 0. When input is 0, then PMOS is on and output is connected to VDD, so output is 1. So, that means when we are applying 1, then output is 0. When we are applying 0, then output is 1. So, that's why it is known as CMOS inverter. So, itself CMOS technology works on the CMOS inverter. So, this is the basic concept why sometimes we use CMOS inverter word, sometimes we see CMOS design, but CMOS is the full form is basically complementary metal oxide semiconductor. So, the word is complementary here. So, it behaves like an inverter. From this diagram, this is the equivalent circuit of this circuit, CMOS inverter. Both the transistors are behaving as a switch. So, when NMOS is on, this is behaving like a small resistance, and when PMOS is behaving as a switch. In case of low input, the NMOS is behaving as a off switch and PMOS is behaving on switch with having very small resistance. So, this is the equivalent circuit of CMOS inverter for both the condition, input 1 and input 0. Here you can see that voltage transfer characteristic of CMOS, or sometimes this characteristic is known as transfer characteristic of the CMOS. So, transfer characteristic is between input voltage and output voltage. So, we have seen in the operation whenever input is low, output is high, but here in this graph you can see that initially when input is very low, in that case NMOS is completely off, like NMOS is in the cutoff region, whereas PMOS in the active region, where the PMOS is replaced by a small linear resistance. So, here you can see that PMOS in the linear region. Once you increase the input, so whenever you increase the input, the NMOS transistor goes into saturation where PMOS remain in the linear. This is the situation. Here you can see that at this point the situation is NMOS transistor in saturation and PMOS transistor in the resistive region, and hence the output start decreasing. Whenever we come at this point, just at this point here, both NMOS and PMOS are behaving as a saturation region. So here you can see that this is the saturation region for both the transistors. Then whenever input is very high and output is reduced from a certain label, that means output is basically VDS. So when VDS is less, then definitely NMOS enter into the linear region and PMOS in the saturation region. So here you can define the region of operation of these transistors, and at last when output is very low, like VDS is very low and input is very high, then NMOS is behaving in the active region, whereas PMOS is off. So this is how you will get this curve. So this is the voltage transfer characteristic of an inverter. Here you can see that the symbol of these transistors. So NMOS can be denoted as gate, drain and source. Gate, drain and source. There is a 4 terminal also. This is known as body terminal. But for simplicity, in this course, we will see the stick diagram and layout preparation. So for the discrete design, we are not considering the 4th terminal, which is the substrate terminal, whereas you must know there is a great significance of substrate terminal when we talk about the integrated circuit technology. So here we are not showing the 4th terminal. So this is the simplest symbol of NMOS and PMOS, and in terms of switch you can represent these transistors by using open and closed switches. Now let us see the logic or Boolean expression equivalent of that CMOS inverter. So CMOS inverter can be replaced by a NOT gate. So here you can see that this is equivalent to the NOT gate, and for NOT gate we know the truth table. Now with the help of, this is very important and asked in the examination, the implementation of various Boolean expression or logic gates using the CMOS technology. So using the CMOS technology, we can implement any Boolean expression. So for example, in this slide, you can see that 2 input NAND gate. So we know the function of 2 input NAND gate, which is y equals to a dot b bar. Here this bar is representing complementary. So it is very easy to implement this Boolean expression using the CMOS technology, because CMOS technology is complementary MOS. So if there is a whole bar, then the logic is very simple. What is the logic? Just see what is the operation over here. So here you can see that there is a AND operation. So for AND operation, the thumb rule is NMOS should be connected in series. Whereas OR operation, suppose there is a plus, OR operation means plus sign, AND means dot operation. So if there is a OR operation, then NMOS must be connected in parallel. And for PMOS, the duality property is applicable. I mean to say, in case of AND operation, parallel connection; in case of OR operation, series connection. So by using this concept, easily we can implement any Boolean expression. So for example, for this gate, just see there is a dot B. So dot means we have to connect NMOS in series. So we have connected 2 NMOS transistors having input A and B in series. And I told you that PMOS is complement to the NMOS. So if there is a series connection, then PMOS must be connected in parallel. So it is very simple. Whatever is the expression given to you, just implement PDN, pull down network. Just implement pull down network, like network of NMOS transistors. So implement this network of NMOS transistors, and by using the dual network property, just implement PUN by replacing series connection by parallel and parallel connection by series connection. So here you can see that input A and B are given to this PDN network in series combination, and A and B is given to PMOS transistor in parallel fashion. So here at this output we will get A dot B bar. So this is a simple implementation of 2 input NAND gate. And this by using this concept of this, we can implement any Boolean expression. So my suggestion is, first implement this NMOS network, and by seeing this NMOS network, you can design the PMOS network. Okay. So let's see one more implementation. This is the 2-input NOR gate. So NOR gate, we know that this is the OR operation. So for OR operation, I already told you, for OR operation, the NMOS transistor must be connected in the parallel fashion. So you can see that NMOSs are connected in parallel, and by duality property, you can implement PUN. Here PMOSs are connected in series. So this is how you will get A plus B bar. So this is very simple to implement any Boolean expression using the CMOS technology. Here one more example is there, A dot B plus C dot D. So for and it is definitely must having bar. This bar is below, but it is above that expression, whole bar. So if whole bar is there, then you can directly apply the concept as we have implemented NAND and NOR. But if whole bar is not given, so definitely you have to add one additional inverter at the end of your total circuit design, PDN and PUN. So here we will see for both the expression, with whole complement and without whole complement. So let's see, A dot B, that means A and B must be connected in series. C dot D, C and D definitely must be connected in series. And there is a OR operation between A dot B and C dot D. So for making this OR, we have to make a parallel connection. So here you can see that A, B and C, D are connected in parallel. Now this whole network is PDN. PUN is just dual of PDN, like A and B are in parallel, C and D are in parallel, and here these two are parallel, so here these two are in series. So this is how you can implement. So here you will get A dot B plus C dot D whole bar. Now suppose this bar is not there, so you will get this whole complement. If I want that this whole bar is not there, then definitely I have to pass this Y from this inverter. So here you will get Y bar. So this is how, by adding one additional inverter at the output, you can implement this CMOS implementation of any Boolean function. So this is how you can implement any logic circuit. Here you can see that this is AND OR invert. So it is known as AND OR invert, AOI implementation. This is AOI implementation. Similarly, you can implement OR AND invert using this logic. And in case like if this type of expression, suppose Y equals to A bar plus B dot C plus D bar. Suppose this type of expressions are there, that means there is no issue. Here input is A bar. So to implement A bar, you have to again add one additional CMOS where you will apply A as an input and you will get A bar at the output, and this A bar must be connected in the PDN and PUN. So first we have to implement this A bar and D bar, then only you can implement this function. So this is how you can implement any logic expression. So this is again one of the compound gate. Now come to the main topic, which is the stick diagram of that particular CMOS inverter. So for stick diagram, there are few rules that you should know. This stick diagram is the simplest diagram which provide the information about various layers like metal layer, diffusion layer, oxide layer, etc. By using the color coding, we can identify the layers. So this is basically a simple interface between the symbolic circuit and the actual layout. So one is layout. Layout defines the actual area of the circuit, actual dimension of the circuit, and circuit is basically the symbolic representation. So there is an interface between layout and the circuit, which is known as a stick diagram. So there are few general rules are there. General rules like there is a layer connectivity. Layer connectivity, like If the same layer touching each other, that means there is an electrical connection. If different layer are there, that means, or they are not connect until a contact is shown. Like different layer do not connect unless a contact is shown. Same layer without connection they are connected, but different layer, if they are crossing each other, there is no connection until unless you make a connection over there. Similarly, transistor form kaise hoga? Polysilicon crossing the diffusion form a transistor. One is polysilicon, and if polysilicon layer is crossing the diffusion, that means it is a transistor. For making the contact, you can make a square or circle with black color. Crossovers without electrical connection, there are like one is black color layer, one is blue color layer, they are crossing each other, that means they are not connected. If you want to connect them, then they have to make a connection. These are the general rules. Like if we talk about the specific CMOS rules, so to separate NMOS and PMOS, we have to add demarcation line, like dotted line between NMOS and PMOS, which is known as demarcation line. To represent VDD and VSS, the horizontal metal lines are used for designing any CMOS. For implementing NMOS, N diffusion and P diffusion, we are having some diffusion rule, like P diffusion and N diffusion must not touch each other. So separate we will design N diffusion and P diffusion. To make the substrate contact, we require N-well and P-well formation. Arrangement, transistor arrangement like series can be represented by zigzag and parallel can be replaced by the U shape if we are implementing CMOS transistor. Color coding are there. So N diffusion is represented by green color, P diffusion is represented by yellow or brown color, and polysilicon is represented by red, and metal is represented by blue. These are the color coding. You must remember these color codings. So now with the help of these general and color coding rule, we can easily design any stick diagram. So let's say metal is represented by blue, poly is represented by red, N diffusion is represented by green, and P diffusion can be represented by either brown or black, or by using these symbols also we can represent. Like in case of exam, you cannot use multiple colors, then you can use this also, like dotted, then dark, then light dotted, bold dotted lines. So these can also be used, but generally we use the color coding. Now rule number 1, there if these two are connected, one blue, second blue, that means there is a electric connection at this node, because same color are crossing each other. Here also there is an electrical connection, but there is no electrical connection because one is red color, one is blue color. So there is no, this is known as crossover. If you want to make the connection, then I have to make a contact with the help of circle or square with black color, like here also. So this is rule number 2. If I want to design a transistor, then one poly should be connect and diffusion. So this is the formation N polysilicon and N diffusion, polysilicon and P diffusion, N diffusion, P diffusion connecting polysilicon. These are making transistor. If contact is shown, that means this is not a transistor because we have connected these two nodes. If they are not connected, that these are forming a transistor. Next is this is the demarcation line. So this is how you can make NMOS and PMOS separate. Now just see the example how we can design a stick diagram of any circuit. So in this slide, I drawn the stick diagram of CMOS inverter. So there one is PMOS, one is NMOS. There is one input, one output, one supply, one ground. So first of all, just make two lines to represent these VDD and ground. So we have seen that they can be represented by a power rail horizontal lines. So supply and ground is represented by metal. So that is represented by blue color. So this is VDD and this is ground. Now I have to make two transistors, one PMOS, one NMOS. So to implement PMOS, P diffusion must be crossed by polysilicon. So brown color line is crossing with red color. Red is representing poly and this is representing P diffusion. Here to implement NMOS, this is N diffusion and again this is poly. So this is representing, this crossover is representing PMOS, this crossover representing NMOS. Now I have to connect these two. So if I want to connect these two, that means I have to make this connection. And to form a wire, definitely I need a metal. So I add one metal line which is represented by blue and I made these contact with the help of black color. So this is how I have implemented PMOS, this connection and this connection. Now I have to apply input. So I tied both the gate with the help of this poly and we can apply directly input over there. Poly to poly, like this line, poly to poly is directly connected. So there is no need to make a black color over there. Now to make the output, because this is already a blue line and to take output we need another metal layer. So I have added this metal layer. So there is no need to add this black color contact over there. So this is how you can easily design any stick diagram of any circuit by using this color coding. So this is the simple stick diagram of CMOS inverter. So this is how you can implement a stick diagram of any NAND, NOR or any compound gate with the help of the general rules of stick diagram. So this is all for this lecture. Thank you so much.